Hello grade 8s, this is Mr. Miller and welcome to lesson 9.1 on analyzing graphs of linear relations. So in number 1 here it says to make a table of values from the graph. So the first graph is looking at the radius of a circle versus its diameter. And of course you probably all know what the relationship is between those two things, but let's pretend we don't know. So with a radius of 1 we have a diameter of 2. So see, r equals 1, d equals 2. So I'm going to write in here, when r is equal to 1, we get d equals 2. The next point we have r equals 2, d equals 4. 2, 4. And the next point we have is at 3, 6. And the next point is at 4, 8. And of course, you're recognizing the pattern here, 5, 10. Whatever you have for r, you have twice as much for d. Now, even if you didn't know that, I mean, the question here, the next question is, what is the diameter of a circle with a radius of 8 centimeters? So one thing that you could do is you could draw a line, and I'm just going to do a nice blue line here, and I'm going to make sure that it's got a little bit more thickness to it than just 1. But of course, you know, if a circle has a radius of 0, then the diameter is also 0. And I could just extend this pattern on, and if I went far enough, I'd be able to figure out that when r is equal to 8, you'd have d equals 16. So I could use the graph. That's one thing I could do. Or if I'm smart and I realize that d is always 2 times r, I can do 2 times 8 to get my answer. And of course that will give you a diameter of 16 centimeters. So a number of ways that you can do that. When you're analyzing the graph, you can use that graph to extend or extrapolate beyond, that's the technical word for it, and figure out if we went far enough in that direction, we'd be able to get to r equals 8 and you'd have d equals 16. Of course, you could actually just look at the table of values and say, well, it's going 1, 2, 3, 4, 5, so if I go 3 more, 6, 7, 8, that's the correct r I'm looking for. I could just go 3 more spots in d. So 2, 4, 6, 8, 10. 12, 14, 16. So 16 is the one, the diameter that we're looking for. And the next question is asking, what is the radius of a circle whose diameter is 22 centimeters? So, I mean, once you have it figured out what that relationship is, of course, you can just do 22 divided by 2 to get your answer, which is r equals 11 centimeters. But of course, you could go along in D until you reach 22 and look at the corresponding R if you continue the table on that long. Or you could certainly have the graph go as far as you need to figure it out. But yeah, I mean, it's definitely faster just to do that calculation, dividing by 2 to figure it out. Now, the next question is a good question. Just asking about whether it's reasonable to include a point on the graph for r equals 4.5. So let's just take a look at where that would be. So with r equals 4.5 right here, does it make sense to have this point right here included on the graph and have a diameter of 9 centimeters? And well, sure, of course it does. So you need to give a little bit of explanation for that. So here's the explanation that I would give. Okay, so I would say yes, because of the fact that the radius of a circle could be any real number. In other words, it doesn't have to be a whole number. So you could have a fractional value for your radius, or you could have a decimal value for your radius, and there's nothing wrong with that. And the same thing goes for diameter. So with that in mind, it does seem reasonable here to have our dots connected and consider every possible radius between 0 and 1, between 1 and 2, and every possible diameter between 0 and 2 and 2 and 4. You can have anything in here. So connecting the dots is okay. That's not always okay in a graph, but we'll see if there are any situations where it might not make sense to connect the dots. Okay. The next question is number 2. And in number 2 it says that Nikki is making a graph of the data in the table of values. So it's got the time worked T in hours, so 1, 2, 3, and 4 hours. And in each case you get a corresponding pay. So for 1 hour's work you get $11 pay, 2 hours work you get $22, 3 hours you get $33, 4 hours you get $44. So it's asking which one of these graphs shows this data from the table. So, well, we might want to just zoom in on these two graphs and have a closer look. So let's do that. I just have a real close look at these two graphs. Here's what I can do. I'm just going to label my points here. This first point looks like it's at 11 and 1. So $11 paid for $1 work. Sorry, $11 of pay for 1 hour of work. And certainly this looks like 22.2 and this looks like 33.3. So you might think, oh yeah, this kind of makes sense, 44.4. Now let's take a look at the second graph, graph B. Well, it looks like it's 1.11 and 2.22 and 3.33 and 4.44. So wait a minute. That seems to make sense as well. 1 hour of work, you get $11 pay. 2 hours of work, you get $22 pay, and so on. So you might be confused at this point thinking, don't they both seem kind of right? Is one better than the other, or are they both acceptable? So here's what I would say in this particular case. I would say that while both graphs could be representative of the same data, graph B is more conventional. So the reason for that is that typically when showing how a quantity changes over time, we put time on the horizontal axis. So the other thing, also, pay depends on time worked. So since pay is the dependent variable, that is to say, it depends on the time worked, it goes on the vertical axis. So when you're thinking about things and you're saying, okay, does pay depend on the amount of time worked, or does the amount of time worked depend on pay? And so usually you calculate your pay from the amount of time worked. That means pay depends on how much you've worked. And so if this depends on that, that makes this the dependent variable, and that means this is the independent variable. Typically, dependent variables are put on the vertical axis, whereas independent variables are put along the horizontal axis. So that's just typically how things are done in math. So the dependent variable goes on the vertical axis and the independent variable goes on the horizontal axis. So now let's take a look at the next page. We've got a few more things to look at here. Number 3 says look at the points on the graph to complete the table of values. So we've got 1, 8, and 1, 8 you can see is this point right here, 1, 8. The next point is 2, 16, 2, 16. So what's the next point? 3. And if we continue the same pattern, 8, 16, adding 8 to that, 24. And it seems to look like it's at that level, $24 in cost. And next we have 4, and we're assuming this is going to be 32. If you continue that pattern in the table, it seems to make sense. If you look at where this is vertically on this scale, it looks like that's a 32. So we're looking at cost of posters. The number of posters is either 1, 2, 3, or 4. And the costs are $8, $16, $24, and $32 for those particular number of posters. So if you want to know the cost of 6 posters, you could certainly continue to make dots along here. Or you could recognize that you look at the number of posters and you multiply by the cost per poster, which looks like it's $8 per poster, and that will give you $48. Of course, the other way is you continue the table of values, you go 5, 6, so 2 more steps on here. So you go 40, 48, and that gives you the cost for 6 posters. Now, the next thing we're looking at here in part C, it's asking, would it be reasonable to have points in between the ones on the graph, and explain? So this one is a little bit different than some of the ones that we looked at on the previous page, in that it doesn't make a lot of sense to have points between the ones on the graph, because you probably can't buy a fraction of a poster. It doesn't really make a lot of sense to talk about buying a fraction of a poster. You know, you can say the cost of 1 poster is $8, the cost of 2 posters is $16. Could I buy 1.5 posters, please, and pay, you know, $12 for that? Yeah, it doesn't really make a lot of sense. So that concludes this lesson. Thanks for watching, and have yourselves a great day.